Hello everyone, I am Dharmi Javia, student from SEM 1 degree ICT at Marwadi University. Today I am here to give presentation about traffic light control. Here some about statement of the problem. Traffic congestion is an increasing problem in cities and suburbans spend more of their time commuting to work, school, shopping and social event as well as dealing with traffic light jams and accidents and so on. Traffic become heavy in all directions, more to and from cities as well between suburban locations nowadays. Suburban business location require huge parking lots because employees have to drive. There were few buses or train or trolleys to carry scatter work to their workplace. The hope of reduced congestions in suburban had not been released or realized. Long commutes and traffic jams could be found everywhere nowadays. In this counter-based traffic light control system, controlling can be done automatically without manpower. While using counter-based circuit, we can use many ICs like IC 555 and IC 4017. Further, we can modify the microprocessor-based traffic light control system by replacing microprocessor with a microcontroller-based traffic light control system because in microprocessor chip there are RAM and IO ports are not present in single chip, but in microcontroller all the above mentioned things are embedded in single IC. Now introduction. As we all know, the name of the project is Traffic Light Control. The automatic control is in engineering and technology is a wide generic term covering the application of mechanisms to the operation and regulation of processes without continuous direct human intervention. When someone analog circuit or any embedded system is used to control the traffic light, where no manpower is needed, is called automatic traffic control. The fundamental idea of this simple electronic project is to control the traffic. Traffic lights are used to control the vehicular traffic. In the modern era, everyone has used different type of vehicle, resulting in raise to the number of vehicle. Traffic light has proved to be an amazing way to stop the vehicular collision and control the traffic jams in today's modern era, where everyone owns a different type of vehicles. Designing of a system to control counter-based automatically traffic light control circuit is designed by 555 timers IC and decade counter. The timer generates pulses with appreciate as per theoretical calculation, and these pulses are fed to 10 state decade counter. The 10 state decade counter can count up to 10 pulses. So for every peak at clock, the counter admits it as an event and remembers it. The number of events that counter memorized output by corresponding pin. The 8085 microprocessor is a popular microprocessor and used in industries for various applications. In this microprocessor based traffic light control circuit, the traffic light are interfaced to microprocessor system through port of programmable peripheral interface 8255. So the traffic light can be automatically switched on and off in desired sequence. In the microcontroller based traffic light control system, the pin of the various input and output ports of the microcontroller are connected directly to the leads. It permits and relief accident free control as a separate set of signal has been assigned to a direction. As we all know, the indication of lights in traffic light. There are three types of light: red, yellow, and green. What does the red indicate? The red indicate the red light instruct to the driver to stop. What does yellow light do? So yellow light instruct the driver to wait if the red light is next, or get ready if green light is next. And what green light will do? Uh, we all know what green light does do. Green light just say instruct a driver to go. You are free now. You are not stopped. So if we need to create a design or a circuit, we need so many components. I have described 8 components over here. 9 volt battery would be input battery. I have used DC power supply. Resistors, capacitors. Here I have used 1N419 diodes. 555 IC timer as a pulse generator. 4017 IC counter. Main IC of the circuit, we can say. Potentiometer control the timing of pulse generated by 555 timer. And LEDs. We need three color LED: red, yellow, and green out as an output LED. Now, resistor. What is resistor? Resistor restrict the flow of electric current. For example, a resistor is placed in series with a lead to with LED to limit the current passing through the LED. I have shown the symbol of resistor. What capacitor will do? Capacitor, it is store the electric charges. They are used with resistors and timing circuits because it takes time for capacitor to fill with charge. They are used to smooth carrying DC supply by acting as a reservoir of charge. So we are using capacitor. Now 555 timer IC. Here I have shown the image of 555 timer IC. The 555 timer IC is an integrated circuit or a chip used in a variety of timer, delay, pulse generator, and oscillator applications. The timer IC is general purpose IC that can be used for precision time pulse generation, sequential timing, time delay generation, pulse width modulation, pulse position modulation, and linear RMP generation. The 555 can operate in both astable and monostable modes with a timing pulse ranging from microsecond. Here I have used the astable mode. In this counter-based traffic light control circuit, we have used IC555 because the timer generates pulse and these pulses are fed to 10 stage decade counter. The 10 stage decade counter have a memory of 10. So we can store 10 memory. Here I have shown a schematic diagram of 555 timer IC. Here 1 indicate ground, 2 for trigger, 3 for output, 4 for reset, and 5 for control, 6 for threshold, 7 for discharge, 8 for VCC. I have given one table. It indicates pin number, name, and purpose. What it do? So pin number 01, ground, connect to ground, low is equal to 0. Pin number 02, trigger, out rises, interval starts when input is below 1/3 VCC. Pin number 03, output. This output is driven to plus VCC or ground. Pin number 04, reset. Timing interval can be interpreted by connecting it to low. Pin number 05, control. Control access to the internal voltage divider. Pin number 06, threshold. Interval end when the current is greater than control. Pin number 07, discharge. Open collector may discharge the capacitor. Pin number 8, VCC. Positive supply between 5 volt and 18 volts. Here I have used 9 volt battery supply. So 4017 IC counter. IC of main IC of the circuit. I have given one schematic diagram right hand side. Here, the IC 4017 is a versatile IC of the CMOS family which has got the wide range of application. The 4017 is a stage Johnson counter having 10 decade outputs. Input include a clock, a reset, and a clock inhibit signal. The clock input circuit provide pulse shaping that allow unlimited clock input pulse rise and fall times. These counter are advanced. One count at the positive clock signal transition if the clock inhibit signal is low. Counter advancement via the clock line is inhibited when clock inhibit signal is high. A high reset signal clears the counter to its zero count. The decoded output are normally low and go high only at their respective decoded time slot. Each decoded input remain high for the one full clock cycle. A carry-out signal completes one cycle every 10 clock input cycle in CD4017 and used to ripple clock the succeeding device in a multi-device counting chain. In the counter-based traffic light control system, we have used decade counter because the timer generates pulse and these pulse are fed to 10 decade counter. We need to memory it, store that. Then 10 state decade counter have a memory of 10. It can count up to 10 pulses. Not just they count for 1, it count up to 10 pulses. So for every peak at clock, the counter admit it as an event and remembers it. The number of event that counter memorized up to by corresponding pins. Now, our one more component, diode. What does it mean by that? A diode is the simplest two-terminal in an internal semiconductor device. It allows current to flow only in one direction and block the current that flow in the opposite direction. The characteristic of a diode closely match to that of a switch. An ideal switch which open does not conduct current in either direction and in closed state conduct in both direction. So this is the symbol of diode. Now, light emitting diode. Light emitting diode is the LED, and here is the symbol of LED. LED are semiconductor device like transistor and other diodes. LED are made out of silicon. What make an LED give off light? There are the small amount of chemical impurities that are added to the silicon such as gallium, arsenide, indium and nitride. When current passes through the LED, it emits photon as byproduct. Normal light bulb produce light by heating a metal filament until it's while hot. Because LEDs produce photon directly and not via heat, they are far more efficient than incandescent bulbs. When a light emitting diode is forward biased, electrons are able to recombine with electron holes within the device, realizing energy in form of photons. This effect is called electroluminescence. Electroluminescence is an optical and electrical phenomenon in which a material emits light in response to the passage of electric current or to a strong electric field. Here I have shown a LED. This is the lens case. This two connect, it's a wire bond, and this is a reflective cavity. From here we can see the light. This is called semiconductor die. This part and this is anvil and this is post. They both are lead frame. We are generally confused between which leg is anode and which leg is cathode. So remember that every short leg is cathode and every long leg is anode. I have shown here a schematic diagram. Here this is 555 timer IC. This is 4017 IC, counter IC. This is diodes. This is LED. Here red. This is yellow. This is green. Here we have used capacitor, 9-volt battery supply, 10 microfarad. It's a capacitor, resistor. Now this is multi-sim circuit. I have created this circuit. I'll show in multi-sim. So this is my multi-sim circuit. I have used less so I have connect all component as shown in my schematic diagram. Okay? The circuit start with a DC supply of 9 volt that is provided to directly IC 555. I have used your virtual time, and there are one more. It is rated. I have used your A based, A stable. Working in a stable mode, and another one in which I say is in monostable mode. So the timer is used in a stable mode, as I say, to make sure we can control the capacitor to increase the time period. To control time period of wave generated, we use resistor connected to the discharge pin of the timer on one end, and another end to the threshold and trigger pin shorted together. On increasing the value of resistance, the time period of pulse increase and vice versa. Similarly, when the timer is operating in unstable mode, the frequency of output waveform can be calculated by simple formula. I'll show that formula. Okay. Here this is the output waveform. Firstly, I'll show the output waveform. So this is the output waveform. When it's in blinking mode, it will go up to 1. It's blinking continuously, so it's 1, constant 1. After that it decreases, so it stop blinking, so it directly goes to 0, and after that 0 it's stable until another LED will glow. So another LED will glow up to 1. After that it will also, the process would be same. So now, so as I say that we can calculate it by a formula. So here period of output waveform, T is equal to T on plus T off is equal to 0.693 C R1 plus 2 R2. Output high state duration, T on is equal to 0.693 C R1 plus R2. Output low state duration T off is equal to 0.693 C R2. Duty cycle is equal to T on by T on plus T off is equal to R1 plus R2 by R1 plus 2R2 into 100%. Because it is a duty cycle, so we need to multiply by 100%. Pulse repetition frequency PRF 1.44 divided by C in bracket R1 plus 2R2. In the above formula, I have used T, it means time in second. C is for capacitance used in farad, and R1 and R2 in ohm, and they are capacitor, resistor. In case if R1 and R2 is equal, then duty cycle equation become like this: T on by T on plus off is equal to R plus R divided by R plus 2R into 100%. If R plus R is equal to 2R divided by R plus 2R is equal to 3R. So 2R by 3R into 100. R by R cancel, 2 by 3 into 100. It means 67% would become duty cycle. By changing the value of R1, R2 and C, the pulse repetition frequency of the 555 timer IC, a stable multi-vibrator circuit output can be changed. The output of the timer is given to the decade counter by connecting the output pin of the timer to pin 14 of the decade counter. Here, the decade counter has 10 output pins, 0, 0 to 09, which give output for one pulse each. We also have pin 12, which is used to cascade to 2 decades counter to increase the count 20 pulses. However, cascading more than 2 counter result is reducing the efficiency of the circuit. Pin 0 to 3 are attached to 1 and 4149 diode each, and then they are shorted, making it N or get and finally connected to red LED. Pin 0 to 4 and pass through diodes, shorten and connect to yellow LED. Pin 0 to 6, 06 to 09 are connected to green LED. For the first 4 pulses, one of the input from 0 to 3 is active sequentially and red LED will glow. For the next 2 pulses, the yellow LED glows and then the green LED for the next pulses. The diode are attached to prevent the circuit from shortening, as it blocks the output for the pin when it is not forward bias. I will show this in multi-sim while running the circuit. Each LED is connected to a resistor before being grounded to provide a sink and prevent it from prevent circuit from burning. Now we can see working principle. The traffic light is made with the help of counter IC, which is mainly used for sequential circuits. We can also call it sequential traffic lights. Sequential circuit are used to count the number in the series. The main IC is 4017 counter IC, which is used to glow red, yellow and green LED respectively. 555 timer IC acts as a pulse generator, providing an input to the 4017 counter IC. Timing of glow of certain LED lights totally depend upon the 555 timer's pulse, which we can control via potentiometer. So if you want to change the time of glow, you can do by wearing potentiometer having responsibility for the timing. LED is not connected directly with the 4017 counter, as the lights won't be stable. Here I have used combination of 1 and 4149 diode and the LEDs in order to get appropriate output. It can be used to avoid the vehicular collision for traffic jam and collision and traffic jam. The project is just one way controller. Main drawback of this circuit is that You can never have a exact timing with however you will have the best estimated, because we are not using here a microcontroller. As I said, in microcontroller there are ROM, RAM and IO ports are in same IC, so it is very useful for modification. Significance of the study. So, it will help in reducing the occurrence of possible collision or accident and thereby improve the confidence of the driver and pedestrian lighting through the highways. The project to allay the fear of time wastage as at the junction because unevenly direction of traffic system. Since the system is capable of working for 24 hours uninterrupted, thereby assured constant availability of traffic control service, hence reduce human effort and energy. It is saying that the point is exactly saying that now it is working 24 by 7. So human should not have to stand over at traffic signals to stop the vehicles. A vehicle, it just change the color by their own by the set of time, so it can so the vehicle can stop by their own. Now, conclusion. What I have concluded that we have constructed a simple traffic light control system. This system can be improved by adding a potentiometer instead of RI that can control the display time for each LED according to need, and also adding a transformer for conservation from AC to DC voltage that allow this circuit to work in real life applications. It can be further improved by using density based traffic control system with the help of microcontroller. Thank you. Now I'll show the multi-sim circuit and run that circuit. Here I'll start circuit. See, the red LED will start blink. It start now. Now see, the yellow one is glowing. See the green one. Here timing of glow is depend upon the 555 timer. So if we need to make that the LED will glow fast, then we can control via potentiometer. If we so you can do by warming the potentiometer having the responsibility of for the timing. Uh, Here, as you can see, the timing of changing in LEDs. For the first 4 pulse modulation, one of the input is active sequentially and hence red LED glows. For the next 2 pulses, the yellow LED glow and the green LED for the next 4 pulses. Here the diodes are attached to prevent the circuit from shortening as it blocks the output for the pin when it is not in forward biased. So here, as we said, that it all depends on timing. We can adjust it from potentiometer by potentiometer, and this 4 pulse module, it can be used that first this glow, second this timing varies. It indicates stop, yellow indicate wait until green turn, then you may go. So I have shown you the, now I'll show the, so I will use oscilloscope to show the waveform. Okay. Now it will change. So we need to change this. Yeah. Yeah. You can see this. Yeah, it's done. So this is the waveform for the circuit for this LED. Now it's going forward. It's 0 because they are stable. While it's go to yellow, it become high. Let's see it now. It's okay. Thank you everyone.